right. Hello, everyone. Thanks for joining my talk, Context is King, How to Successfully Manage Applications Running in Kubernetes. My name is Matthias Luebken. I'm really stoked to be here. Online, offline, I don't know. It's my first virtual conference. Yeah, I'm looking forward to it. All right, let's get started. My name is Matthias Luebken. I'm a PM for all things Kubernetes and infrastructure related at Instana. We do a monitoring tool, and today, I'd like to tell you a little bit of our experience, of our lessons learned through the last couple of years of how we see Kubernetes, how people are struggling with Kubernetes, and what, one take on how to tackle this. It will, cover a lot of things. So I hope, you bear with me. It will also be very, tangible afterwards, so you can do things. And I hope, we will stay in touch and, can learn together on how to keep going. All right. So, preparing the talk yesterday, last minute polishing, and I saw this awesome tweet. Kubernetes is very good at solving problems. It introduces you into your environment, right? And I think this is something that we can all resonate to. Kubernetes is an awesome tool. And that said, it also, adds a lot of things that we need to manage, right? So, what are these, and how can we, tackle these? So one thing that, Kubernetes brings along, it's the dynamism, right? The dynamic Kubernetes application. Kubernetes, brings a lot of new attributes if you, follow it, along. And, here are a couple. So the first one is scale, right? Kubernetes applications have, tend to be more on the side of the microservices, right? You have many more smaller, fine granular services that you need to tackle. And, depending on your architecture, there might be, to hundreds or thousands of microservices. Also the change of speed, right? So something that, we in the DevOps world, we are trying to get to. Kubernetes is really getting us there, right? The increased change of continuous deployment is really something that you see in Kubernetes. Ephemeral, another attribute, right? The amount of containers that are coming and going is just so rapid that, traditional ways of looking at this and our traditional tools are not always working. And polyglot, right? The technology stacks, the right tool for the job is really something that came with containers, and, we're seeing more and more Kubernetes. So, these are kind of the, some attributes, and we might think of others. So, what are the challenges that bring these attributes, right? And, when you're managing applications, when you need to look at what your application is doing, you need to understand which of these many components that are affected by something that you're investigating. You need to understand of what metrics to look at, of like what you're looking at a component, need to understand it, and then understand by the metrics it provides. You need to interpret these, right, and make sense of these and distill it to the right amount of information. And you need to correlate in different information out of these applications. Let's look at it as an example, right? An example is always the best to get the thoughts going and get to aligned. And you probably have something in your mind already, but let's center our discussion on one example. So this is a normal search application. On the top hand, you would have like a Spring Boot application, based on a JVM, obviously running on container, running in Kubernetes. On the lower hand of side, you would have an Elasticsearch cluster, right? And it's scaled out. It has four nodes here, depending on how you want to run it. But it, it has these four components. And again, running obviously JVMs, process, containers, and hosts. Let's, look at a typical problem, right? Your service might act differently of what you were expecting. And there can be multiple root causes. So you start looking into your cluster, you'll start looking into different nodes. But it might happen if you're looking at the lower corner here, the lower hand side, that you have a problem with the host, right? That the host has some I/O problems. There might be problems on the Elasticsearch application itself, right? It might be having some thread issues, thread pool issues, or even like typical garbage collections issues. The point is that within these many things, you need to understand which of the component is affecting your search. At the end of the day, you care about the search. The search is something that you provide to your customers, and you need to take care of the different. You need to understand where to look at and how to correlate different information to each other to make sense of the bigger impact. Microservices are big, and this is like the star death of dependencies. It's actually a nice little gimmick we have in our tool that spans on all these dependencies, and this is actually the core to it, right? You need to understand these dependencies and how to interact with them. All right, so how to go about it, right? How do we understand this? And the way that I'm trying to talk with customers about it, and that I personally trying to make sense of it all, is like a layered approach. The first one that I think is important to realize, and it's not me if you talk about anyone caring about microservices in this world, is talking about like you don't care about like low-level metrics, but you care about your service. And if we're taking a typical online service, we have these requests, errors, and duration, a typical core KPIs that you care about. And this is the starting point of what you care about. And understanding the dependencies up and down, obviously. Now, additionally, and we took some examples here out of the Kubernetes world. Additionally, for Kubernetes, we need to understand the resource allocation. We are setting limits. We have something distributed in our pods. We've created the deployment, as in this example show. We have a stateful set or a daemon set, whatever powers our service. We need to understand on how these things relate to each other. And the third layer that that I think is important to reason about is the underlying layer of compute, the underlying infrastructure area. And this is something where you rather are interested in the utilization, the saturation, and the errors. And we're going to talk about that in detail. But this is the core idea. This is the pattern that I want to describe today in a little bit detail is managing Kubernetes application. It's important to not only think, and depending on where you are, where you're coming from, you might tend to one or the other. But this is the core idea. There are these three broad perspectives: service, Kubernetes, and infrastructure. And this is how we want to go about it and look at it. You can also think about other perspectives, right? These three core perspectives, as I've called them, is I think a very sensible starting point. But obviously there are others. And shout out to my colleague Michele. We had the argument yesterday, and he said, EUM or business metrics are so much more important. Why can't you talk about infrastructure, right? And he's right? In certain areas, in certain scenarios, other perspectives might be more important. But I do think that for everyone getting started or getting more and more into the production space of Kubernetes, it's important to have these at least in mind. And the other thing that I would like to mention is that very often what I'm seeing with customers, especially bigger ones that are getting started with Kubernetes, is that they are having dedicated teams, right? We used to have these, these ops areas, and the whole DevOps movement. We have to, I've started to integrate that better to development, but we still need specialties, right? Everyone, at least that's what I'm seeing, with a very big customers and also very proficient, very good customers that have like a high technical expertise, they're still saying, for certain areas we need specialties, and Kubernetes is obviously one, right? It's a new thing. So the point I'm trying to make is you might have different teams. I've called them here DevOps and Ops, and you cannot come up with other terms. The point is try to create a coherent understanding. Try to make sure that if you are navigating a problem, if you're managing an application, make sure that everyone has a common understanding of their own problem and their other perspectives. And again, service, Kubernetes, infrastructure perspectives as the one. All right, so we've got these three perspectives, great. Now what? So the rest of the talk, I would like to talk a little bit of like how and what to observe here. I'm obviously not going to talk into every detail, but I should give you a sense. And from what I know is you will have access to these slides. So there's tons of links into the slides. So I hope you'll have something to reach out. And how do we put these into context, right? How do we understand like how our service and the infrastructure is working together? All right, let's get started with services. Again, the starting point for everything. The definition of service for me is something that is user-facing, right? A logical service that is user-facing. It's implementation independent, so it can run on Kubernetes, but it can also run everywhere else. And it provides some kind of service that some user cares about. And this can be an internal user, this can be a technical user, or this can be an end user, hopefully, right? And the point is that, you want to think about, and some folks are using, the SLO, SLI way of looking at this, but you care about some service level that you're providing someone else. And looking at the implementation specific KPIs can be misleading. Looking at the host CPU can be misleading. So you want to start on a high level, service level kind of information. And especially in Kubernetes, there are so many tweaks and knobs you can turn that at the end of the day, you want to make sure that you have your service level in line. All right, so what do we want to observe? To answer that question, you first need to decide on the granularity of the service, right? So in Instana, what we do is that we have a type. We have for example, HTTP or database type, and we have a name, and then we, per default are associating that to a service. So if you have it scaled out horizontally, that's all one service. In Kubernetes, there are different other means, typically a label selector. But you need to decide on the granularity of your service, and it really depends on where you're coming from. If you're writing a modern microservice application, or if you're coming from a WebSphere application server type, it really depends. But that's usually you probably have an already good understanding of what that is. The other part is if you're monitoring your service, if you're looking onto what to monitor, what to observe, is you need to see if you have higher level assemblies. Right, a typical one would be an application. Now the application type is very different, and then we can argue for minutes of what an application actually is. Good news in Kubernetes, there are some means of some agreement on that with Helm and certain operators and the application TRD. The point is, think about how you combine these services and if there are bigger assemblies that you care about. And then what you do, right, you measure and observe and alert on the RED metrics or the golden KPIs. So for those who haven't heard about these, the golden KPIs are from the Google SRE book, and where they're talking about the latency, the traffic, the error, and the saturation of a service. The one that I'm just, resonates a little bit better with me is like, keeping the saturation out of the application for the service, but rather putting them on the infrastructure, and talking about the RED method that Tom Wilkie has described with the rate, errors, duration. But you should, the broad idea is the same, right? I'm looking at my service, I'm understanding on how much of this service is called, what the latency, the duration of my calls are, and if I'm seeing any errors. Here are some examples, right? So on the left-hand side, we have our dashboards. And on the lower right-hand side, we have an example from Grafana or Prometheus. And obviously with, a gazillion other tools, you have different examples. But, it's something that, you want to get started in and, make sure that you have common understanding of the tool and a dashboard that everyone agrees on. Now, on the way of how to measure it, right, there are multiple gazillion ways of things. You obviously can do it with a vendor like us or any of the others. But if you try to get your feet wet, hands dirty, there's actually a lot of nice tools within the ecosystems already. If we're talking about services and how to measure them, you basically need to decide between two camps. The one hand is that you really directly collect these metrics and measure these metrics. And there are, again, tons of libraries out there. Client Java for Prometheus is one, a JMX exporter or micrometer exporter if you're measuring them. And we're just talking about Java here, right? And for your language, for your areas, we would have something different. Something that we and others do is like, why not infer these from tracing? So the concept of, measuring the trace through the service dependency is really, really crucial to for many other cases like distributed profiling or seeing how things relate to each other, like dependency mapping, but also for services, right? You can infer a lot of things. The good thing about this is that, you can change the granularity, which I talked about before, like how you want to slice and dice your services. You can decide that later on, right? If you say like a certain endpoint shouldn't be on there, it's something like a configuration change rather than a code change. Anyway, basically two camps, or one over the other. If your solution is trace-based and the traces are sampled, make sure that you store these metrics separately. Here are two links from how to do this with Zipkin and Red Hat. We don't sample these, but with doing it like this is also an option. All right, let me do a short time check here. All right, so Kubernetes as the second layer. Kubernetes is obviously, for this conference, but obviously also everywhere else, in the center of the universe. Again, please look at the services first and then look at Kubernetes, or make sure you've got the services view in place when you start looking at Kubernetes. But then obviously we need to understand what Kubernetes is doing. And probably not a lot of introduction needed for this conference, but Kubernetes as a cloud OS, for orchestrated workloads, takes care of a lot of things around scheduling, orchestrating, allocating resources, and making sure that our distributed workload are parallelized, high availability, and can just run in the distributed setup. So what do we care about? If we're looking at Kubernetes, what do we care about? If you are managing your cluster itself, and this goes a little bit away from the application, but something that we see a lot of people are interested in is, you need to look at the cluster, the control plane. Depending on where, if you manage it yourself, and depending on what kind of managed Kubernetes cluster you have, you want to capture some core metrics around, basic components like the API server, controller manager, etc. And you also want to make sure that the nodes itself are intact. For our applications, more importantly, is the distribution state and the resource setting, right? So depending of what kind of resource you used, right? If you use the deployment or a daemon set or a stateful set, you're looking at different desired, current, up-to-date, available, and unavailable parts of your distribution. And you need to make sure that they are all balanced, right? That the desired state is eventually into that the actual state is actually turning into the desired state, and that you really understand that what you wanted to have in the system is actually there. Now this can differ, right? If you have some rescheduling events, if you have some update events, obviously the desired state is not always there. But depending on your application, you have a certain threshold of what you want to see and what you expect. The other important piece to observe, and this is something that I'm basically having daily calls with customers about, is the resource settings, right? Setting the right resource settings, setting the right CPU requests and limits, providing the right resource quotas to teams is something that you need to get familiarized with, and you need to monitor early on, right? Because as things are evolving into production, we've seen it a couple of times that it's really hard to reason about in the later stage. So please start measuring them from the beginning. Again, an example, right? So we have our Kubernetes dedicated dashboards and we have the Grafana dashboards. Nothing too fancy, right? You need to understand, again, the requests, the status of things, and have a gauge or something of understanding on how far you are. On the state of things, on how to measure, again, good news with Kubernetes, a lot of things are built in, right? Kube state metrics is an awesome project, and there you would have the majority of information that you like. Exposed with Prometheus, so very easy to ingest into different backends, whether it's whether you decide to run your own Prometheus setup, or you decide to run something like Instana or other vendors, using these metrics is straightforward. On the control plane level, if you are tackling that space, there's a couple of components like Kube API server, etcd, scheduler, controller manager, all have them all metrics endpoints, and you can use them. Metric server is another interesting project, and if you used kubectl top, you would have experienced them. Also something to look out for and make sure you understand. All right. So we've got services and Kubernetes. Let's jump to the last layer. Now, a lot of people are, we are living in the serverless space, but maybe not in the Kubernetes enterprise crowd so much. But still, there's a lot of people, having said, like, why do I need to look at infrastructure? Why is that perspective is important? And the thing is that although they are down there and they're a layer below in this thinking, they still are the cause for many problems. Maybe not the majority of problems, right? The majority of problems in Kubernetes in microservices are most likely somewhere else. You have service dependency problems. You have problems with something on the Kubernetes configuration. That said, if you have these and you lose track of these are really hard to find, right? So I'm trying to make the case that, try to keep the infrastructure perspective in mind and make sure that you've got them covered. Again, warning sign, warning note, don't care about these as a starting point. Care them as a supporting function to your service and to Kubernetes information. Adrian Cockcroft did a pretty good blog post or a presentation on this way back, but he basically says it's useless. Now, this is just about if you just look at this, not as a supporting function, as a supporting function for troubleshooting, root cause analysis, and all kinds of utilization. It's really, really important. So in the sense of what to observe, the point is that there's many ways of what you can observe. The best way for me to reason about is taking the use method by Brendan Gregg. So we're talking about utilization, saturation, and errors. And the way he defines it is basically for every resource, and with resource meaning any physical server component like a CPU, like memory, like storage, like networking, taking care of these and understanding of what is the utilization, so the average time that the resource was busy doing something, serving something, the saturation, so the degree of which the resource has extra work, which it can service, often some work queued, and the count of errors that this resource throws. So use method, utilization, saturation, errors. Try to think of these if you're thinking about like the underlying infrastructure information. And don't take this for granted, but it's like it's a general pattern that you think of. Obviously, the type of resource, the type of application, it might slightly differ of what you want to look at, but it's a good way to get started. So, again, a simple example, we're looking at a host here, right? And, obviously CPU and memory is central to it. But we're also looking at different, kind of metrics into the host itself. Something that you can't see here on the screen, but context switches is one. And, we're also looking at different CPU usage details, as in the different, user system weight, nice and steel metrics. Again, these are pretty standard dashboards, and with every tool you would have something like these. Something else, and I just found that it's funny that these dashboards are so large. So I apologize that you can't see them, but I just found these awesome on the size of things. Is JVM, right? So something language runtime specific is very much needed. JVM as a very powerful platform, and also very good platform to introspect a lot of detailed information that you want to observe, and make sure that you have a common understanding. So these were just two examples, and obviously the amount of languages, we said at the beginning, polyglot languages is going to be huge. Now the good news is, again, in the cloud native Kubernetes space, with Prometheus you get to a decent amount. There are multiple ways to capture these metrics, and Prometheus exporters are the most prominent one. So if you're, for example, looking at host metrics, the node exporter is a very good start. And I've talked earlier about the GMX exporter, about getting JMX metrics from the JVM directly. The Docker daemon has, for example, has an exporter built in. Now, for certain, if you really dig a little bit deeper, you might need more native instrumentation, and the exporters don't work that much, especially on the JVM metrics. So that's something to reason about. But again, lots of tools out there that cover you. All right, so we've got service, we've got Kubernetes, and we've got infrastructure. Now, last but not least, we need to understand on how to correlate these, how to make sense of each layer, and make sure that we understand this information into context. Make sure that we understand the service relates to Kubernetes and the Kubernetes relates to the infrastructure. For this, I'd like to provide you with two basic suggestions on how to go about. The first one is wherever you are capturing these kind of metrics, and whichever system you use, try to make a standard of what kind of tags you want to use, and use human readable tags, because you're going to query a lot of different data sources, and different data types, different data sources. If we are looking into the open telemetry space, an upcoming standard of how to do this all, basically, we can get some good inspiration on what to do. So the number one in this regard, and it's actually mandatory in open telemetry, is that you use a service name, right? So once you have an idea of the granularity of your service, pick a service name that you can reason about, and use this without any data source that you're looking, whether it's in the service, in the tracing, whether it's in the metrics part, in the Prometheus, or even in logging, right? Try to use the service name to reason about it. But obviously, to connect these to other things, and depending of perspective you're taking or where you're coming from, you need additional information. On the container name, here are some suggestions on the image, the container name, on the host, and the Kubernetes. Try to pick a couple of these to make them unique, and having some ways of looking up, having a lookup. Which brings me to the second suggestion, and that's using a unique identifier. The open telemetry, again, if we're taking that as an inspiration, or saying if you have a service name and you have a service instance, which is their idea of these single things that cover that are the horizontal entities of something that is servicing the bigger service, capturing a unique IDs on these, and the service namespace, you should have a global identifier. And with these global identifiers, then you're also making sure that everything is unique, and you can capture everything information, correlate them to each other. Some concrete examples, and again, you will have access to the slides afterwards. Some concrete examples here, for example, Grafana, are capturing the trace ID in the logs, and they're using a common service tag, as we've discussed before. An example here. The SoundCloud, an actually pretty interesting example, as we've seen here, they're using the pod IP to then, before saving the span information, which then can be correlated to service information, or getting that out of the before they are saving the spans, are having a reverse IP lookup and looking up that information before storing them. Speaking of telemetry, which we used before, they're on the discussion of making this all automatic. So some good news on the horizon that there's going to be more standards of how to do this all automatically. All right, this brings me to an end for today's talk. If you want to take up some key takeaways, we've got three core perspectives to take care about. Look, start with your service, correlate that to Kubernetes and infrastructure. Make sure you have a common understanding for you individually and with your team. And try to create perspectives. There's if you're on the route of Grafana, there's a lot of Grafana dashboards out there, and trying to create these perspectives and creating holistic context by linking these tags together. Here now a little bit a small plug, right? With Instana, play with instana.io. You can actually give it a try. We have these built in, so we're looking forward to your feedback. This is the summary slide, just for the reference, and that is it. I'm going to be available in the network chat lounge. Really looking forward to it. My first virtual conference, so please show up. This is so exciting to me. And apparently we also have a booth, right? I mean, a virtual booth, isn't that exciting? So, come by. We're going to be there. Colleagues are going to be there, and we're going to give you a live demo. And with that, have a nice conference. Thank you very much for listening to me, and talk to you soon.